name's Glycolysis, and we will be discussing Chapter 4, Describe the General Metabolic Pathways of Carbohydrate Metabolism. Glycolysis, in its literal definition, is the breaking of glucose. Glycolysis is a 6-carbon molecule. Glucose is a 6-carbon molecule that initiates the start of glycolysis by using 2 ATP. Glycolysis is the process in which a 6-carbon sugar glucose is broken down into 2 3-carbon pyruvic acid molecules with a net gain of 2 ATP and the release of high-energy electrons. Glucose, in the end result of glycolysis, is converted into 2 3-carbon pyruvic acid molecules. And when it says net gain of 2 ATP, it's because it uses 2 ATP but gains 2 more, so it forms 4 ATP. And as I mentioned before, glycolysis begins with 2 ATP and then 2 phosphate molecules attached to each end of the glucose, and then a process called cleavage or cleave separates the glucose molecules into groups of 2 3-carbon molecules, and then that phosphate ends up attaching again to both sides of each group, and those reactions release hydrogen atoms that are then paired to pass on to the hydrogen carrier NAD. NAD gains hydrogen atoms, which creates NADH, and then the 2 ADP on each pair creates 2 ATP. Okay. The citric acid cycle. The 2 pyruvic acid molecules lose a carbon molecule and combine with a coenzyme to form acetyl-CoA. And then they combine with a 4-carbon oxaloacetic acid to form citric acid, which is displayed here as citric. Then carbon dioxide is released due to the loss of a carbon molecule. So it loses a carbon molecule. The carbon molecule lost becomes carbon dioxide, and that happens twice because there are 2 cycles in the citric acid cycle. And then it also forms NADH as well as FAD and FADH. And then ATP is also created here, but in this image it is displayed as GTP, which is equivalent to ATP. And the citric acid cycle, it actually forms, and because it forms 2 carbon dioxides, 1 carbon lost as CO2, the second one lost as CO2, it actually forms 2 ATP because the cycle happens twice, depending on how many times citric acid passes through. And the citric acid cycle is an anaerobic metabolism, which forms little ATP. The electron transport chain is a series of enzyme-containing complexes that pass electrons. These would be considered the complexes. Complex. And the complex is also displayed here on the dots. The inner mitochondrial membrane. The high-energy electrons NADH and FADH are handed to the electron transport chain to synthesize ATP, meaning NADH, FADH, they pass through the electron transport chain to synthesize ATP. The electron that passes through the chain loses its energy. As it goes on, it loses more and more energy. It is then transferred to ATP synthase, located here, an energy complex that adds a phosphate to ADP to form ATP. The electron transport chain generates 26 to 28 ATP. The total yield of ATP per glucose molecules is 32, but it varies. Thank you for listening. My name is Glycolysis, and this was Chapter 4 on describing the general metabolic pathways for carbohydrate metabolism.